This is the second of the modules on ordinal data analysis. In the previous module, we have seen that categorical data can be of two types, nominal or ordinal. This can lead to a variety of contingency tables and cross-classifications. Ordinal data arises when the data is categorical, but with the particular property that the categories can be ordered. We can, of course, continue to use the standard techniques for nominal data, such as logistic regression, for this situation, but we will lose out information on the ordering of categories. In the last module, we have looked at two measures of association, the gamma measure and Summers' D criterion, to quantify the extent of association when we have ordinal variables. We have defined two basic concepts, the concept of concordance and the concept of discordance, and seen that the summary measures are some functions of the difference between the number of concordances and the number of discordances. In this module, we will define two additional concepts and also look at tables where we might have nominal versus ordinal classifications. We will introduce the concept of Kendall's tau and also the concept of a Reddit analysis. Learning objectives for this module. We shall first define a summary measure of association called Kendall's tau B. Next, we shall consider situations where we have nominal ordinal association, that is, one variable is nominal and cross-classified against another variable which is ordinal. Finally, we shall look at more detail at a popular technique for nominal-ordinal association called Reddit analysis. In previous modules, we have looked at two summary measures of association for ordinal data. These were the gamma measure and Summers' D. In this module, we shall look at another variant of the gamma which was proposed by Kendall. In its sample form, it is given by tau b hat equal to c minus d by square root over n into n minus 1 by 2 minus tx into square root over n minus 1 by 2 minus ty. Tx and ty are, of course, the number of ties on the x variable and the y variable. To refresh your memory, concordance and discordance are defined as follows. We assume that we have two pairs of individuals and that the measurements on the two variables are given by x and y. Thus, for the first individual, the two variables are given by x1 and y1, and for the second variable, the second individual, the two variables are given by x2 and y2. We have a situation of concordance if x1 greater than x2 implies y1 greater than y2, or x1 less than x2 implies y1 less than y2. What this means basically is that the individual who is ranked higher on the x variable is also ranked higher on the y variable. We have the reverse situation of discordance if x1 is greater than x2 or y1 is less than y2, or x1 is less than x2 but y1 is greater than y2. So if we think of the two ordinal variables as x and y, this means that the individual who is ranked higher in terms of the x variable is ranked lower in terms of the y variable, and hence we have a discordance. You will recall that the gamma measure and Summers' D were defined in terms of concordance and discordance. Kendall's tau b has an interesting property in that it can be represented as a Pearsonian correlation coefficient. To this end, let us define for each pair of observations XAYA and XBYB XAB, which is equal to the sign of XA minus XB. This means that XAB is equal to minus 1 if XA is less than XB, equal to 0 if XA is equal to XB, and equal to plus 1 if XA is greater than XB. Similarly, YAB is equal to sine of YA minus YB, and this is equal to minus 1 if YA is less than YB, equal to 0 if YA is equal to YB, and equal to plus 1 if YA is greater than YB. We calculate the value of XAB and YAB for all pairs AB. Now, if we look at the n into n minus 1 ordered pair of observations AB, assuming that A is not equal to B, it is possible to show that summation XAB YAB over A is not equal to B is twice C minus D, where C denotes the number of concordances and D denotes the number of discordances. Summation A not equal to B XAB square is given by 2 into n minus 1 by 2 minus T x, and similarly for summation A not equal to B YAB square. Summation A not equal to B XAB is equal to summation A not equal to B YAB is equal to 0, and the implication of all this is that tau b hat can be written as C minus D over square root of n into n minus 1 by 2 minus Tx into n into n minus 1 by 2 minus Ty. Now, the idea of concordance and discordance were first introduced for continuous variables. In case the samples can be ranked on both the variables so that Tx and Ty and Txy are all equal to 0, C plus D is given by n into n minus 1 by 2, and gamma hat is equal to D of Yx is equal to tau b hat is equal to C minus D over n into n minus 1 by 2. The coefficient of rank correlation was originally proposed by Kendall and is called Kendall's tau. It is the difference between the proportion of concordant and discordant pairs out of all pairs of observations. Similarly, we may choose to use other correlation coefficients to define yet other sets of ordinal measures based on C minus D as a numerator. If equally spaced scores are assigned to the rows and to the columns, then we can use a version of the Pearsonian correlation coefficient. If rank type scores are used, this correlation becomes a generalization of Spearman's rho. We can similarly use the same idea for Kendall's rank correlation. For a review of the literature on the use of other correlation coefficients, you are referred to the book by Agresti or the publication due to Lancaster and Hamda. Let us now move to a situation where we have ordinal nominal association. So, for example, We may be interested in comparing two groups, say men and women, in terms of a response variable having ordered categories. So say for example, this could be the extent of belief in abortion. So the extent of belief in abortion could be classified as do not support, somewhat support, indifferent, and strongly support. So in this case, the support for abortion is an ordinal variable and gender is a nominal variable. As I said before, we can choose to ignore the fact that one of the variables is ordinal and continue to use odds ratios. However, we can get more informative measures based on probability of x greater than y. We define two concepts. The first is the delta measure, which is probability of x greater than y minus probability of y greater than x. Where we assume that x and y are two independent random variables from the two distributions corresponding to the two levels of the nominal variable. So for example, x denotes the satisfaction for men and y denotes the satisfaction for a randomly chosen woman. In the case when satisfaction does not differ with gender, we would expect probability x greater than y to be equal to probability of y greater than x, and hence the delta measure to be equal to 0. Similarly, the alpha measure is a ratio measure, and we can use the value of the alpha measure to make inferences about the extent of association between the ordinal and nominal variable. Let us come to a very popular technique called Reddit analysis. We assume that we have an R by C table with the rows being the levels of the nominal variable and the columns being the levels of the ordinal variable. Now suppose that it is possible to assign ordered scores, mu j's, to the columns. We can then find the mean response in each row given by mi equal to summation over j mu j pi j I, where pi j I denotes the conditional probability distributions for the j categories of the ordinal variables given that I is fixed at I. So pi j1, for example, for j equal to 1 to c would denote the C levels of satisfaction or the C levels of support for a belief for, say, males, and pi j2, j equal to 1 to c, would be the probability distribution denoting the same ordinal variable for females. So the MIs can now give one summary measure of satisfaction for each of the rows. Consider the marginal distribution pi plus j, j equal to 1 to c, of the response variable y. This is obtained by summing over the rows corresponding to the nominal variable. The jth Reddit Rj is the average cumulative probability within category j of the ordinal response and is given by Rj equal to summation k equal to j minus 1 pi plus k plus half times pi plus j for I equal to 1 to c. That is, the jth reddit is the proportion of individuals below category J plus half the proportion in category J. The reddits have the ordering R1 is less than R2 and so on up to RC, and they can be used as category scores. The mean reddit given by Ri equal to summation over J Rj into pi Ji can be computed for each value of I, that is, for each level of the nominal variable. The utility of this is that the mean reddit Ri has an easy interpretation. Note that Ri is equal to the probability of yi greater than y star plus half times probability of yi equal to y star, where yi is the response category for a randomly selected observation in row I and y star is the response category for a randomly selected observation from the marginal distribution pi plus j equal to 1 to c of y. This can be done by using the reddit function from the reddit library of R. The usage of the reddit function is highlighted on this slide. So, the usage is reddit xg with an optional reference argument, where x is a numeric vector of data values or a matrix of crosstab data. G is a vector giving group of data, or when x is a crosstab, number 1 or 2 when group is in the row or column of crosstab. And reference is an optional argument which denotes the code or the label of the arbitrary reference group. This slide also shows some examples on the air quality data, where we look at the ordinal variable corresponding to ozone and the nominal variable corresponding to month and perform reddit of xg or reddit of xg with 5 as the reference group. I encourage you to download and install the library and to try out these commands for your own understanding. A seminal paper which popularized the use of reddit analysis is How to Use Reddit Analysis Due to Bross, published in Biometrics in 1958. This is an application paper which illustrates reddit analysis of data from the Cornell Automotive Crash Injury Research Program. The reddit analysis is summarized in this table. So, column 1 to 4 denotes the quantities, the frequencies which are required to calculate the reddits, and finally the entries in column 5 are the reddits corresponding to the categories none, minor, moderate, severe, serious, critical, and fatal. Now, the purpose of this study was to look at the role of 3 factors: ejection from the vehicle, the seated position, and accident severity. Here we see a crosstab by these factors and the corresponding reddit values. Note that there is a big variation in the reddit values. Now, it is also possible to denote the variances for each of the reddit categories, and this is illustrated on this table. Now, often we find that in many studies there is considerable variation about the mean, but the variances tend to be relatively constant. This is not so for this data. Now note that the average RIDDITs have a probability interpretation. It is the estimate of the chance that an individual in a given class is worse off than an individual in the reference class. For example, the average RIDDIT for drivers with passengers who are not ejected in moderately severe accidents is 0.27. This means that the probability that an individual in the above class will experience an injury worse than the individual in the reference class is estimated as 0.27. Coming back to our table of variances. Now, the variances in a class can of course be calculated using standard procedures, and a striking feature of this data is that it appears that the variances also differ from category to category. So, for example, the variances within some of the categories are very small. Some of the non-ejected drivers with passengers in extreme accidents exhibit a bimodal kind of distribution. The reference set has a central peak so that the distribution somewhat resembles the normal distribution. Non-ejected drivers with passengers in minor accidents appear to follow an exponential decay curve. For more details on this analysis, I refer you to the paper by Ross. To summarize then, we have looked at ordinal data in this module. We have first looked at ordinal versus ordinal classifications, that is two variables, both of which are ordinal, and to the concepts of the gamma measure and Summers D criterion, we have added another very common measure called Kendall's tau. We have seen that it can be expressed as a correlation coefficient. We have next moved on to the concept of nominal versus ordinal data and seen that it is possible to define two measures, the alpha measure and the delta measure, in terms of the probability of x greater than y, where x and y denote the two variables. Finally, we have explored in details a very popular technique for nominal ordinal classifications called RIDDIT analysis.